We know chemical reactions are associated with valence electron in atoms located in the outermost shell. Because electron was not discovered until 1897 by Thomson, many chemical names given before that are confusing or even misleading, such as cation and anion. This is a battery. There are two electrodes. One is positive, called anode. Another is negative, is called cathode, respectively. Where the two prefixes an and cat means up and down in Greek, respectively. In history, anode and cathode were named by Michael Faraday, who became the father of both electrochemistry and electromagnetism, when our understanding about electricity was in its infancy. Physicists in those days couldn't tell the difference between animal electricity or amber electricity. Perhaps you can also remember in your chemistry lessons, a positive ion is called cation, and a negative ion an anion, which were also introduced by Faraday. But can you see the inconsistency in such a traditional naming convention? You may wonder, why did Faraday make such a misleading names? Why do chemistry teachers often defend such a problematical names? That is our topic today. Around 1830, Faraday was puzzled by seeing some moving stuffs in a solution in which two electrodes is connected with a battery. The experimental setup is called electrolysis. To be specific, two strings could be identified. One moves toward the anode, another moves toward the cathode. Faraday must have thought that he must have found some new chemical sensitive to electricity. He was eager to give them a proper names. To do so, he asked the English polymath, William Hewell. Based on Faraday's new observation, Hewell suggested using a Greek word ion, meaning to go, to name the moving stuffs Faraday observed. Based on which electrode those ions would go to, he recommended two ions. One is called anion, another is called cation. In doing so, an anion would move to the anode, and a cation would go to cathode. Without a second thought, Faraday just accepted Hewell's suggestions. But that is how the trouble began. In fact, Hewell's suggestion was nothing new, but borrowed from Aristotle's idea in the ancient Greek, which states that objects fall because they seek their natural place. And for generations before Newton established his law for gravity, it had been taken for granted. Still, it seems very strange that Faraday didn't pay his attention to the Coulomb's law that had been established in 1785. Perhaps he thought the Coulomb's law was for static electrical charges rather than the moving electricity or the current. As I mentioned above, Faraday might have considered ions as a kind of new substance that cannot be made by Dalton's chemical elements proposed in 1803. You see, in those days, electricity would appear so different or novel from chemicals people had known. At least wouldn't consider electricity as a subatomic entity. It seems he could have estimated for the first time the element of the electrical charge by simply dividing the electrical charge in 1 Faraday by the Avogadro constant, but he didn't. Today, in many chemistry textbooks, you can find such a diagram for galvanic cell when it is used as a battery. The electrode for generating electron in the circuit is called the anode instead of cathode. A chemistry teacher would explain that an anode is where cations are being generated, called oxidation. This argument seems reasonable before the discovery of electron. In fact, before 1897, nobody knew electrons are also produced together with this cation in the oxidation reaction. Therefore, it was concluded that no negative particles are generated in an oxidation. After 1897, when J.J. Thomson discovered electron as the first subatomic particle, people realized that electrical current is due to moving electrons in the conductor originated from negative electrodes and through a node and return to the positive electrode. It was also revealed that the electrode associated with the oxidation in the galvanic cell also generate electrons. Those electrons form the electrical current in the circuit. Therefore, it doesn't make sense to call this electrode as anode. It seems strange such a misleading cation and anions introduced by Michael Faraday are still in use today in the school. Without using such inconsistent names for ions, students could study modern chemistry easier and faster. What do you think? Here are the consistent names for electrodes and ions. If you like this talk, please like, subscribe, and make a comment. And keep your little bell activated. See you next time. The blue curve is theoretically calculated, which is to be explained soon. As you can see, the coordinates of the 3 planets, namely Mars, Earth, and Venus, can be quantitatively predicted. Is that beautiful? I remember my teacher said Newton was merely puzzled by the first push because he believed that his mechanics to fix the fundamental problems of the standard model, isn't it? Let's remember C.G. Ozawa, my favorite conductor, who created joy. Arrhenius claims CO2 is the chief absorbent on his paper, page 260, without any direct experimental evidence, such as this one demonstrated with this Newton's cradle. As you can see, something must have been transferred among the metal balls. But what is this something?